Hey everyone, hope you all are having a great day. This is Hajra Mughal. Welcome to my YouTube channel Physics Unlocked. Welcome to the second part of our lecture series on dimensions. In our previous session, we explored the first advantage of dimensional analysis, which is to verify the correctness of an equation by checking if both sides have the same dimensions. Today, we will discuss the second advantage of dimensions, which is to derive the possible formula. So let's dive in. Deriving a possible formula using dimensional analysis. So dimensional analysis can be used to derive a possible formula. Deriving a relation for a physical quantity depends on the correct guessing of various factors on which the physical quantity depends. Let us see an example. A particle is moving in a circle of radius r with uniform speed v and acceleration a is produced due to the change in the direction of the velocity. The magnitude of the acceleration depends on two factors: the speed, symbolized v, radius r. If the acceleration is proportional to different powers of these quantities, guess the formula for A means acceleration, using the methods of dimension. So basically what they have given a situation that acceleration is dependent on the two physical quantities, the speed and the radius, and we don't know what power and how they are related to each other. Either they are in a fraction form or a multiplication or a division form. So we have to guess the formula, we have to derive the formula by using the dimensional analysis. So how we are going to do that? So first of all, we will make a data, that what data they have provided to us. In this example, what data is given to us. So first thing that is given is the three quantities, the acceleration, velocity and the radius. And from previous lecture, I have made a screenshot that the velocity, the dimension of the velocity is Lt minus 1 and the dimension of the acceleration is Lt minus 2. So on the basis of these dimensions, we can make a data. The dimension of acceleration is Lt minus 2 and the dimension of the speed is Lt minus 1 and the dimension of the radius is L, because radius is measured in meter. Okay, now what is the requirement? We have to derive a possible formula for acceleration. Now this is the first heading is data, then second is requirement. Now how we are going to solve this formula? Let the acceleration of the particle depends on the speed v and the radius r, which is already given in the question. What you are going to do, you will write the acceleration is directly proportional to both the quantities and you will provide a power a and b. Let's suppose if any physical quantity depends on three factors, then you will write third factor here along with the power c. And this is the way you are going to perform. You are going to derive some other physical quantities. Now, when you open this proportionality, so there will be equality and a constant k, and give it name as equation number 1. So next step will be you are going to put the dimensions of left and right side along in this equation number 1. So the dimension of acceleration is Lt minus 2 and the dimension of velocity is Lt minus 1 with the power a, and the dimension of the radius is L along with the power b. In next step, what you are going to do, you are going to break this L and T and you will provide a power to separate both. So L having a power a and T having a power minus a, because minus 1 multiplied by a will become minus a. Now you can see we have 2 L here in a dimension square bracket. So when the base is same, so power will be added. So L, a plus b and T having a power minus a. Step, we are going to compare the powers of L and T. On left hand side you can see the power of L is 1 and on right hand side the power of L is a plus b. So comparing, so 1 is equivalent to a plus b, and for T, the left hand side the power of T is minus 2 and on right hand side the power of T is minus a. So which equation is easier to be solved? So this one, when you cancel out these two minus sign, so a is equivalent to 2, and when you substitute this value of 2, a is equivalent to 2 in this equation, so the value of b will become minus 1. B is minus 1. Now people, you just guess that what we are going to do, what should be the next step? Yes, very good. The next step should be, we are going to substitute the value of a and b in that equation number 1, which you have seen in the previous slide. So equation number 1 was a is equivalent to k, which is the proportionality constant, velocity having a power a and the radius having a power b. Now we know the values of these power. A is equivalent to 2 and b is equivalent to minus 1. So when we substitute the value of a is 2 and b minus 1, so if I want to make r plus 1, so what I'm going to do, I will take that r in a denominator. So the formula will become v square over r. And let us assume, if you have started the formula of centripetal acceleration, so you have just got a click that this is the formula of centripetal acceleration, and in that formula there is no constant, so we can assume that k is equivalent to 1. So this is the formula of centripetal acceleration, v square over r. So this is the way we can derive the possible formula by using dimensional analysis. Just have a quick recap that what we have done. First step, you have to write that physical quantity proportionality to the factors on which that physical quantity depends, and you will provide a power like a and b. Then you will substitute the dimensions on both the sides. You will compare the dimensions of the same physical quantity to find out the values of those powers. Then again you will substitute the powers of the value of those power in back to the equation number 1, and you will get the formula like we have derived. Students, this is one of the very important question that is usually asked in board exams. So let us see the question, that find an expression for the time period of simple pendulum. The time period t may depend upon the mass of the bob of the pendulum, number 2 the length of the pendulum, and number 3 the acceleration due to gravity at the place where the pendulum is suspended. So those who have maybe started the concept of simple pendulum, they surely know that simple pendulum, the time period of the simple pendulum is dependent on 2 of these quantities. So we have to derive a formula. So how to do that? We are going to use the dimensional analysis, the same strategy. First of all, we will write the equation. The time period is proportional to 3 these quantities, and we will give it a power a, b and c. Now it is your task to solve this question, and if you face any problem, then let me know in comment section, so I will provide the solution of this question and will soon attach the solution in this video. Thanks for tuning in. If you like this video, be sure to hit that subscribe button and click the notification bell to stay updated on my latest uploads. I appreciate your support and can't wait to share more exciting content with you.